Okay, in our last section before the AP exam, we're going to take a look at integrals involving our inverse trig functions. And what ends up happening is we are given integrals that are in this kind of format, and we have to identify them and see that, okay, that's going to be inverse sine. If it's in this kind of format, then this is going to be inverse tangent. The a values here are constant values. And if it's in this format, it's going to be inverse secant. Those are the only three we really look at. The only one that I would expect that you might have on the AP exam would be the inverse tangent one. That's the one that shows up most often. Doesn't mean the other ones won't show up, but I would say that's the one that shows up most often. The one thing you have to be careful of is sometimes, especially with inverse tangent, it will look like inverse tangent will actually be natural log. So we'll do an example of that later on. But you just get these kind of relationships down. Remember, a's are constant values. Just ones you have to memorize. So let's look at a couple examples. First one is a definite integral. This one is in the format of inverse tangent, the most closely related to inverse tangent. I know that because there's no variable on the top here. These limits I'll work with in a little bit. The x squared, don't worry about it. I mean, that's in this particular case, the a value is 1. The u value is just is just x squared, so you don't really need a u. The 4 is a constant, so really this is 4 times 1 over a, which is 1 over 1, times the inverse tangent of u over a, which is just x over 1, at 0 and at 1. Leave the 4 out front. So it's 4 times inverse tangent of 1 minus inverse tangent of 0. And here comes unit circle. That's pi over 4. That's 0. So it's 4 times pi over 4 minus 0, which is just pi. So those unit circles, they do slip in with the ones that have definite integrals. If they're non-definite integrals, if they're infinite integrals, then you don't have to worry about it. But the definite integrals you do. Look at a couple more. In this particular case, it's under the square root. Doesn't have anything out front, so I'm thinking, hey, it's inverse sine. Inverse sine is 1 minus u squared. So if e to the 4x is going to be u squared, then u has to be e to the 2x, not e to the 4x, because e to the 4x is u squared. So then find the derivative. Du is 2e to the 2x dx. If you solve that for e to the 2x dx, which is my numerator, see, I divide both sides by 2 or multiply by 1/2. So when I rewrite this in terms of u, it's 1/2 times the integral of, the top part is du, the bottom part is the square root of 1 minus u squared du. That is in the format of inverse sine. So this is going to end up being 1/2 inverse sine of, and again, it's my a value in this case is 1, so it's u over a. U is e to the 2x, so it's inverse sine of e to the 2x, and then plus your constant. Let's look at one where I have something in my a value. So I'm going to write this in the format. When I write it in terms of u, I'm going to write it in terms of a, and I'm going to write it in terms of u. If a squared is 5, then a is the square root of 5. That's the way I'll write it in a moment. If u squared is x to the 6th, then u has to be x cubed. Obviously, we need to find the derivative of that, so du equals 3x squared dx. When I rewrite it in terms of u, the x squared dx is 1/3 of du, so 1/3 times the integral of 1 over, I'm going to write it as the square root of 5 squared plus u squared du. The 1/3 stays there. Antiderivative is inverse tangent, so it's 1/3 times 1 over a, which is 1 over the square root of 5, times the inverse tangent of u over a. U in this case is x cubed. A is the square root of 5 plus your c. They don't matter. It doesn't make any difference if you rationalize that square root of 5 or not. It doesn't make any difference. The only time people get confused on this, or the only time I see people run into trouble on this, is sometimes you can throw problems in there that look like inverse tangent but end up being ln. In this particular case, we could take care of the x squared dx we take x squared dx by letting u be x cubed, and I could rewrite it in a format which was a squared plus u squared, and so that was inverse tangent. In my next slide, watch. This time, if I wanted to write it that way, if I wanted that x squared to be u squared, then u would just have to be x. If u is x, then du is just dx. That doesn't work because I have an x variable on the top. So u cannot be just x in this example. In this example, what has to happen is u has to be the entire denominator, x squared plus 25, because then du is 2x dx, and that extra x and the dx are 1/2 of du. So when I rewrite this, it's 1/2 times the integral of 1 over u du, which is then obviously ln, 2 times the ln of the absolute value of x squared plus 25 plus c. So the only time people get confused at all on this inverse trig stuff is when I throw in there problems like ln. If you can't write it in terms of u squared and a squared, and you have to do something else, you can't take care of all your variables, you might want to try ln as well. Okay, so your last assignment before the AP exam, and then we start working on reviewing for the AP, and we'll finish it up with another unit on integration by parts and some more trig integrals after the AP exam. Good luck.